Okay. Good morning, everyone. You can hear me, right?
Yeah, good morning.
Okay, good morning. Let me share the screen and we can start. Reaction that you can hear and can see the screen. Okay, great. So we are going to talk about correlation analysis. What does it mean and how you can do it or read the data on it. So correlation, as you can see from the name, it's about relationship. But relation, so let's just see what sentiment analysis is in short, and we go further on the correlation. So I think your guys already are aware what sentiment analysis is. It's about determining the emotional tone from text words, whether they're positive, neutral, or negative. So with positive, it means they give, positive vibe from the sentence. And negative, it's more negatory meaning you get from that text. And neutral is just a statement, nothing you cannot consider either a positive word or sentence or a negative one. So sentiment analysis resides with the NLP tasks. It's one of the uh, tools within the toolkit of natural language NLP. So yeah, this is so NLP stands for Natural Language Toolkit. It's a popular open source library for Python that provides comprehensive set of tools for working with human language data. So this is just another description why sentiment analysis is needed. So it helps you to understand, especially depending on the data, to understand customers' opinion on some scenarios, feedbacks, like filtering spam. So spam. So on your email, you can get a lot of spam messages like you got the job. This overexcitement messages that can really show you there are faults, but there are too much excitement, too much positivity, which are considered most of the time as filter. You can identify those with sentiment analysis by identifying what those words are. It's not the only mechanism to identify, to categorize words to be you are that and there, because sometimes with analysis they don't understand, you this word, this I don't know what they could like የአራዳ ቃላቶች maybe, uh, those kind of sarcasm words. They might not understand this kind of words. They might consider them if sarcasm for indicating a positive thing, but it is indicated with a positive word, it might consider it as a positive analysis. So it has these limitations. So that's why it's not the only thing you should do to identify things like that. If depending on the data that you have, it wouldn't matter. But you need to think about that. It's not the only thing. There are different ways of we humans use words, and the models are not there yet to understand every type of saying that we are saying within our language vocabulary. So that being said, when you come to correlation, um, it measures the strength and direction of linear relationship between two quantitative variables. So basically, it's a relation, it checks relation between two variables. So sometimes when you do this quantitative relationship between variables and test the data, you might see when one's increase, the other decrease, or one increase, the other increase. So you might get on your head to come up with a conclusion to say that this particular data is affecting that one, or that particular data affecting by the increase of this one. You might say that that's a legit analysis, but with correlation, the thing you need to be careful is sometimes, maybe most of the time, it doesn't mean whatever relation that you see between variables, it may not be uh, the right answer to just conclude that this particular variable affected that one. So it doesn't necessarily imply by causation. That's why what I'm saying here. It might not necessarily be one is affecting the other to behave that way. It's just sometimes your data can give you that kind of a relation, but it doesn't necessarily be, it might be something that happened. So for example, if we got some data on ice cream sales and drowning, if you see the ice cream sales are increasing while the drowning also increases, you cannot conclude that because the ice cream sales increases, the drowning incident is happening are also increasing. So the ice cream sales are really affecting people to get into this drowning incidents. You cannot say that because it doesn't make any sense. Maybe both of them are affected by another factor that makes them cause to increase at the same time. So it's just there can be a tricky situations that can happen depending on what data that you have. So you just need to be careful on your conclusion at the end because those factors, those relations come from another thing, another factor that you haven't seen. So just don't be quick to decide this cause this one because of this. The data needs to make sense to say that. But it does have just it's written like this here because it's something that is likely to people to create a mistake because what they see with this correlation relation with variables. So you just see the data, understand it, and this correlation makes sense to say this relationship is this. Hopefully get it. So the point is it doesn't necessarily mean imply causation when you are doing correlation between data. So it's what is the importance of correlation? It's really good for predictive modeling, identify relationship between entities, which help you to make predictive decisions in the future as well. There are different types of correlations out there, but some of them are here. This one, the Pearson correlation, the Spearman, the Kendalls. These are different correlation models that you can pass your data through to see any kind of relationship between your datas, your columns. So the first one mainly focuses on linear relationship between continuous variables. So when we say continuous variables, just those values that are more in floats in decimal values, we call them continuous variables. So it helps you to measure if you have a continuous data with Pearson. And most of the time with Pearson, it is assumed that the data is, distributed normally. With Spearman, it is more suitable. You can use it for linear as well, but it's more suitable for non-linear relationship and ordinal data. It's more for those who doesn't have a normal distributed data. You can use it for that one. Kindle, it is use another non-parent correlation measure. It is less sensitive compared to the other for outliers. So if you have outliers in your data, Kindle it's not sensitive to those to affect the data analysis at the end. It's less sensitive. So they have their own pros and cons. So you can pass your data through them and see what kind of output come from Pearson, Spearman, and Condell to identify any pattern. So as always, if there's outliers, it's always better to clean the data from those outliers and pass it to these correlation models to get a more accurate results. So this is just the word that I just use on describing them, just to see what they meant. So after you identify these correlations between data, so between entities, the other way you can also see, instead of seeing a number between values, that is plotting. So visualizing your data, your correlated data is always also a good way to really understand the relation. So scatter plots are mostly used on correlation. It helps to identify relationships, linear and linear correlation. So and there is also the common one, that is a correlation matrix. It is a matrix box visualization that helps you to see the relationship between two entities much clearer. It's a common one. So common misinterpretations, like I said before, correlation doesn't necessarily imply causation. It might sometimes, depending on the data, but not always. So you should be careful of that concept. Outliers, so outliers can really significantly affect the correlation data. So passing a clean outlier-free data helps you to get a more accurate correlation result. So a correlation can be used in different sectors. It's used in finance and marketing, healthcare, to see, the relationship between things, to see how they are affecting each other, or if they are affected by other factors as well. So this is just applications that correlation have been used for. Best practices in correlation analysis, that is data preparation. We already say this one. So putting the data quality as clean as possible, as high quality as possible, will give a better correlation analysis. Choosing the right method based on your data distribution, the data type that you have, choosing the right model to do this correlation is the other step that you should consider in to the right method. And interpretation, that is, uh, once you get those data, the next step is interpreting it, right? What does that mean? So you need to interpret that depending on what the purpose you're using it for. Eh, So that is the last step, how you interpret that data to say, this is a relation that I got. So if you have questions, you can ask, especially what correlation means. You can raise your hand, but let's go to the demo and see some correlation thing. Okay, Nabil.
I just wanted to bring the point that it's generally good practice before using any kind of statistical method or any kind of even machine learning algorithm to always go ahead and look at the assumptions, because every method like Pearson correlation, or whether you're going to do Spearman correlation, or whether you're going to even do logistical regression, they have their own set of assumptions that need to be fulfilled before you can use them accurately. And so it's generally good practice to outline all those assumptions to make sure that your data actually fulfills those assumptions, and to document that so that when somebody goes ahead and reviews your work, it becomes a lot easier, and you can rule out the fact that you can easily rule out misuse of a tool as a reason why something's working well or something isn't working well. I just wanted to bring that up.
Yeah, I agree. Thank you, Nabil, for that. That's a good point that he made. We should always, exactly how he said it. That is a good thing to consider, the right thing to consider. So let's go with this demo. So basically, I don't have to run it, but here I'm fetching the Apple data. So this is just reading it, the columns. So here I'm giving sample headlines for this demo. So it's just some news, some statements on the data. This is just fake. I'm putting here a manual thing. So then I have put this headline as part of the data. So I have rearranged this particular data by the date. So I just want to see create sentiment analysis for this one, for the headlines, and I want to do the correlation between the closing price and these headlines. So here I use TextFlow for the sentiment analysis. So and it provided for all the random text that I provided for it. It gives me the sentiment analysis numbers. So you can see it, right? So 1 is to the positive, 0 is more neutral, and -1, it goes to the negative value. You already know these polarity values of sentiment. So now I have created 2 columns and I have the closing value that I got from the Y Finance. These are created by me right now. So now I want to see the relation between how the hairlines, these hairlines are, could be anything, could be the news about the particular, in that particular dates that were given, that's how much they affect the closing price. That's what the relations that I want to see. So once I have stated all the columns that I need, I use a PCT change. It is a pandas method that calculates the percentage between the current and the previous row. It helps to identify volatility or trends. It's a common method that's used in financial modeling. It smooths these numbers out to give you a much better uh, numbers value. So I use this one on the closed pricing. So basically what I'm doing is, based on the definition, it goes to the next row and it gets first the previous one, which is on this case is 71 minus, that's how the calculation work. The previous one minus the previous one divided by the previous one, it gives you this value. PCT change. It helps if there's any patterns between the previous and the first one, it helps you to capture that particular trend. So based on that, I have done this because the first one, there is no previous value, so it's expected to come in a number. So based on this particular method, I have again rearranged the, remake the data. So I have named this particular one I'm getting daily returns. Named it like this. Now, let's see through the three correlation models that we just mentioned on the slide and see how the data is behaving. So the first one is a Pearson correlation, which I call with the core. I think I have imported it somewhere. Yeah, okay. So you can, it's a Python module, so you can just access it through, it doesn't need an import with the core. It will calculate the correlation. So I'm passing it here. I want the correlation to be calculated between sentiment and the daily returns column. So I'm trying to see the relation between the sentiment values and these reformed values through the PCT change method. So when I calculated it, I get this value with the correlation between the two, which indicates it's slightly going, it's negative, but it's more inclined to zero. So which is, it's showing a zero neutral value. Again, I have done the sentiment with the closed column, which is almost zero. Again, the other part that I did is, yeah, this is just, I shifted the date to be lagging just to see if the two are enough, but if you can see them both are coming almost to zero, these relations. And I'm just putting some lagging on the date with the shift to see if this number is correct, because I'm getting zero values. So which is again zero. So it really doesn't matter. The shifting doesn't make any difference. I'm still getting the relations between the sentiment columns, the sentiment data with the closing price, the daily returns, and with the closing price and the daily returns, almost similar value. I'm getting almost zero, which indicates there is no relationship between those two. One is not definitely affected by the other, and it's almost, there is no relationship between the two columns. I guess there's three columns. The sentiment against close is almost zero. The sentiment against the daily returns is again at zero. It makes sense for me to get this value because the headlines that I give are just random text. They are not particularly related or actual headlines that happens during that time of that Apple data. So I just put for the demo there. So it makes sense for me to get this value because I didn't really give the correct headlines that happened within that date. And I again tested the same logics here with the Pearson correlation. So by default, if you put core only and just pass the data, it will understand it as the Pearson correlation model. When you want Pearson, you can actually define the method here like this. Method Spearsman. I can do the same for Pearson as well. I can do just Pearson, but if you don't give it by default, it understands that Pearson, so it's fine. So for Pearson, I put it like this, and you see the same thing happens. It's almost zero, which again, I'm getting the same kind of relationship with this one, with Kindle, the same thing, almost zero. So I can conclude that there's no that much relationship with the hairline that I choose, those sentiments, again as my closing price, and the daily return that I get by calculating with the PCT change method. It makes sense considering my data was almost fake, the hairline that I give. So that's how these values came. So just try all of them to see any change coming from all of these models. Like I said, they have different pros and cons. Kendall is much good for outliers. I haven't cleaned the data if there are outliers, but the outlier is not the problem. All of them almost have the same result, which indicates there is no relationship between the hairlines that happen on those states again at the closing price at those states. So now we have seen the correlation information and come up with some kind of analysis. The next step, like we said, is visualize it. So I usually use correlation matrix. It's really easy to see it. So with correlation matrix, I pass all the three columns. Where are that? Yeah. So I created the correlation matrix through the Pearson method on the data, the correlation data. This is just dropping if there are non-values. Then I calculated the matrix, then plot it. So if you can see how you read the data is the daily return relation with the sentiment is value is put it here. You see the calculation from this to this. Daily return relationship with sentiment is negative 0.0, which is almost zero. The close with the sentiment, again, almost zero. This is sentiment with sentiment, so it's itself by itself, so you will expect a good relation. So it's data, again, it's on data. So usually the diagonal lines have always number one with correlation matrix. This one, the close with the close, one, the daily return with the close, zero. So this is showing that there's almost no relation between these tables. So one is not affected by other, and there's no relation to conclude. So this is how calculating correlation and visualizing it looks like. Was that a question? Okay. So is there a question? So this is the concept of correlation. Is it clear, or is the demo clear? Germa is asking, can explain heat map site indications. Is it clear now? I think I explained the heat map part, right? The correlation matrix. Okay, Mukhtar, I'm gonna ask you. Germa, is it clear? Okay. So I think how you read the heat map is clear. So you go to one side to this side to see the relations, and okay. Mukhtar said, I see a downward emoji. Can you ask a question? Can you brief about it? Is it about the whole thing or a specific question? Mukhtar, is it just an overview? Okay, so the whole point of this tutorial is to understand what correlations means for a data, how you can do it. So basically correlation, as the same as suggested, it is about finding a relationship between, for example, in your data, you have different columns, right? So you pick those columns that you think might have a correlation, or you don't have to pick, you can do the correlation on all the data and see if you find something interesting that you can come to a conclusion from. So basically correlation, you took two variables or more than that and see if you can find a relation with this. The relation is shown through the numbers between those entities. For this, they have different models that are out there. One, I have mentioned the three of them on the slide. By using them, you can find some kind of numbering value which indicates you whether there's a relationship between one with the other. Hopefully, is that is it? It's clear, Mukhtar? I'm not sure. Okay, so just read the slide, see the recording again, and you can reach out on the group chat or me, Mukhtar. Gabriel, can we take the concussion matrix? What is it? You mean correlation matrix? I'm not sure. Confusion matrix. Accuracy or is that it? So I'm not sure if I understand your confusion matrix, but with the correlation, the most known is the correlation matrix that is helps you to do the heat map. So, I mean, there are different types of models and everything to do this. So maybe confusion matrix is one of them, but it depends on the data. I'm not sure if confusion matrix is enough or for a continuous variables. Most of the data that you have, I think, are continuous. So I think confusion matrix might be for a discrete variable. Sorry, for a discrete variables, not continuous variables. So depending on the data, you decide what's best. I think confusion is for discrete though. Which type of correlation is most recommended to use? Depending on the data again, Daniel. It really depends on what type of data that you have. Like I mentioned on the slide of the definition of each module, there are also other models that you can use depending on your data. If you have a discrete data and a continuous data, the model that you might use is different. So just understand your data and just find the right one for that particular data type. Yeah, I think for the correlation data, the graph that you should use, the most common one, the correlation matrix heat map is common, but also the scatter plots are common as well. So you can use both. Okay. So I used the lag date just to see, because I get zeros on all the model that I used on the demo. I logged the data with the date to see if there is some kind of difference when there is a delay on the dates, but it didn't. So this is just to see if I take back the dates information that I have 10 days or in 5 days back, is there a difference with the correlation between those entities? That's what I used it for. In my case, there wasn't. This is just to be sure we have the right correlation value between now and before, or at some point of time. Is that correct, Miju? Is that understandable? Okay. So any other questions, unclear things, please go ahead, uh, raise your hand or write on the chat. Okay. Then can I get a final reaction that you guys understood the whole concept and we can end the session? Okay. Okay, in that case, I'm ending the recording. Thank you for joining and